So welcome friends. In previous lecture, we have gone through the introduction of this 8051 with its generic name, then the rest of the things related to this 8051, that its number varies depending on different utilities available, then how we can program and what are the different softwares that we can use to program and download that program into your 8051 so that 8051 will be an alive component to be used in different products. So today we are going to discuss about this 40 pins of 8051 microcontroller. If you can see, this pin number 40 is for providing plus 5 volt power supply to this chip. Pin number 20 is ground. Total 40 pins are there. This we are studying dual in line package having 20 pins on one side and 20 pins on other side. Pin number 40 is VCC. Pin number 20 is what you are ground. And then out of this 40 pins, 32 pins are set aside for 4 ports, P0, P1, P2 and P3, where each port takes 8 pins. Okay, in this way 32 pins are set aside for delivering the data or for accepting the data, apart from for some other roles also. For simplicity, I have drawn this diagram like this so that we can study this more effectively. Yeah. This is the diagram. These are the 4 ports: port 0, port 1, port 2 and port 3. Pin number 40 and pin number 20 that we already have studied. Then we are having pin number 18 and 19 to which crystal is connected. This is not crystal oscillator. This is external crystal connected to this 8051 microcontroller so that this electronic clock driven device circuitry device, it is having some internal circuits which needs internal oscillation, and that internal circuit will oscillate with reference to this frequency of crystal. Usually 11.0592 megahertz crystal is connected with this 8089C51. We will find out the reason of selecting this odd frequency also, why not exactly 12 megahertz, why not 11 megahertz, why we are selecting this 11.0592 megahertz. Right now you have to keep in mind pin number 18 and 19 are for connecting the quartz crystal. Crystal uses 11.0592 megahertz. Then pin number 9 is reset. This reset pin is for this setting of initial condition. As soon as we are having this type of arrangement, one capacitor is there, one resistor is there, external switch is also there. As soon as power supply is turned on, this capacitor C start to charge. Okay, and then this initially it is discharged, and as soon as this power supply is turned on, this capacitor start to charge, and then this point goes to high. Then after certain time, again this capacitor C3 discharges to this path R1. Okay, so in this way a low to high pulse is provided on this RST so that microcontroller can start reading from initial memory location. Program can start from initial condition to start the program from beginning, you can say. For that reset is provided, this pin number 9. Even you can means arrangement for resetting 8051 microcontroller externally is also provided. By pushing this switch we can reset this 8051 microcontroller. Then we are having again 3 pins over here. One is EA bar, which is connected to this VCC. EA bar stands for external access. Now your 8051 microcontroller is having limited amount of ROM and RAM on chip, but when that memory is not sufficient, we need to interface external memory with your microcontroller, and when data is to be read from that external memory, at that time this EA bar pin, EA bar, external access bar pin, comes into picture. When external access is to be done, this pin is connected with ground. Then again one pin is there, PSEN bar, program store enable bar. It is again related with the external memory operations. When we are using external memory, at that time this PSEN bar comes into picture, otherwise it is left open. It is connected with ground when external memory is used. ALE we already have studied in 8085 microcontroller also. ALE stands for address latch enable. Now in case of, it is again related to this external memory. In case of external memory, when this port pins are used as address and data bus, at that time this ALE pin indicates whether the bits on this 80 to 87 are address bits or data bits. If it is high, then bits on 80 to 87 are address bits. If it is low, then bits on 80 to 87 are data bits. So ALE discriminates between 80 to 87 whether it is used as address bus or data bus. Then coming on to this ports, in previous diagram, we have said that total 32 pins are set aside for the 4 ports: port 0, port 1, port 2, and port 3. So out of that, port 0 is having this type of open drain connection of MOSFET. Basically, each pin is made up of MOSFET, except port 0, port 2, port 3, and port 1 are having similar structure. We are studying this port 0 right now. If you will go through pin numbers 32 to 39, these 8 pins are set aside for port 0's 8 pins, P0.0 to P0.7, or you can say P0.7 to P0.0. Now each pin is made up of MOSFET. It is having an open drain connection. And as far as rest of the ports are concerned, port 1, then port 2 and port 3 are concerned, it is having also MOSFET as internal structure, but it is having one resistor connected over here at this drain, at this drain, if you can see. This is the 10 kilo ohm resistor. It is usually called as pull-up resistor. So this is internal to your microcontroller. This is also internal to your microcontroller. Port 0 is not having this type of pull-up resistor, whereas port 1, port 2 and port 3 are having internal pull-up resistor. Now what does pull-up resistor do? This pull-up resistor use the flexibility of sinking and sourcing to this port pins. Means if this MOSFET is off, then current will flow like this. Means your port pin can source. Whereas if this microcontroller is if this MOSFET is on, then current will flow like this. Means it can sink. So this flexibility of sourcing and sinking is provided with the help of this pull-up resistor. Whereas in case of this port 0, current can flow only like this. Current can only flow like this. Means no sourcing is possible, only sinking is possible. However, that sinking flexibility can be given by adding an external pull-up resistor with your port pin. So that can be added externally. So except port 0, this port 2, port 1 and port 3 are having this type of pull-up resistor. Now we'll see this actual detailed structure also of this port pins. Means what exactly this port pins, input output pins consist of. Check out, this figure shows us the actual structure. Check out, this figure shows the actual structure. Every port pin is controlled by a single bit. If it is 1 or if it is 0, then according to that, sinking or sourcing of data can be done. Check out, as given here, the below figure shows a simplified schematic of all circuits within the microcontroller which is connected to one of its pins. It states to all the pins except those to the port 0 that do not have pull-up resistors built in. As we already have stated that port 0 is not having pull-up resistors, so this pin represents all the pins of port 1, port 2 and port 3. They are having internal port resistor, this IP resistor, that is port resistor also, which controls whether the pin will be function as output pin or input pin. Check out, a logic 0 is applied to a bit of the resistor P. If a logic 0 is applied to a bit of resistor P, that is port resistor P, then the output, this FET, that is MOSFET, is turned on and current will flow like this. Therefore, it connects the appropriate pin to the ground and current flows like this. Whereas if a logic 1 is applied to the bit of the P resistor, then the field effect transistor is turned off and the appropriate pin remains connected to the power supply voltage and the current flows like this. In this way, sinking and sourcing facility is availed to you in case of this 8051 microcontroller with the help of this pull-up resistor, with the help of this MOSFET. Now in exam, if it is asked to you, explain the port structure, then you have to draw these figures and you have to explain about this pull-up resistors as well as MOSFET, how logic 0 and logic 1s are applied so that sinking and sourcing facilities availed, that you have to write. Next thing we have to check out over here, port 0. Port 0 is having, apart from inputting and outputting of data, it is having some additional function also. In case of external memory, it is used as multiplex address and data bus 80 to 87 also, 80 to this 87. Port 2 is also having 8 pins. It is also used for dual purpose in case of external memory. If you are using external memory, then it uses high order address, that is A8 to A15. These 8 lines, this P2.0 to 2.7 are used as A8 to A15, which carries high order, most significant 8 bits of the memory address. Then port 3 is having the most important dual role in the case of your 8051 microcontroller. Many times this question was repeatedly asked in case of all the universities exams, what exactly dual role port 3 plays. If you can see, port 3 is also having 8 pins, P3.0 to P3.7 and P3.0 to P3.7. Apart from that, some extra functions are written in bracket over here. P3.0 to P3.0 and 3.1 are having dual function in case of serial communication. P3.0 is used for receiving the data serially. P3.1 is used for transmitting the data serially. P3.2 and P3.3 is having the functions associated with interrupts. It plays the role of external interrupt 0, external interrupt 1. P3.4 and P3.5, apart from inputting and outputting the data, they are having functions associated with timers, external timer 0 and timer 1. P3.6 and P3.7 are associated with memory related operations also, means write operation and read operation. In this way, port 3 is having the dual role. Apart from inputting and outputting the data, port 3 controls the functions related to serial communication with RxD and TxD, with functions related to interrupts with INT0 and INT1, with functions related to timer with pins T0 and T1, and with functions related to memory with the pin P3.6 and 3.7, which are designated as RD bar and WR bar over here. Whereas port 1 is concerned, port 1 is having its dedicated function on inputting and outputting the data. It is not having any dual role in this case. So this is all about your 8051 microcontrollers. 40 pins, 32 pins are set aside for inputting and outputting the data. Port 1 is not having any dual role. Port 0 is having dual role. It is used as address and data bus if you are using external memory. Port 2 is used for providing most significant 8 bits if you are using external memory, and port 3 is associated with dual role. It controls the function of it controls certain functions associated with serial communication, interrupt, timers and memory as well. Out of 8 pins of port 3, 2 pins are associated with serial communication, 2 pins with interrupt, 2 pins with timer and 2 pins with memory operation. So this is all about 40 pins of 8051 microcontroller. In next lecture, we'll go through more details about this 8051 microcontroller. Thank you. Stay tuned. Study happily. Thank you.